All right, welcome to lecture 9 and part D. And in part D, we're just going to do more naming, more examples, might help make it a little more sense. We're going to do something a little different with a few different little variations that you need to be familiar with. So let's go ahead and get into it. And in this lecture, again, for naming ionic compounds, basically I'm going to give you the name and you're going to tell me the formula. So for starting off with, how about for iron 3 chloride? What would be the formula for iron 3 chloride? Well, just to remind you how you do that, you write the symbol and the charge of the cation. So that's the iron. And do you remember what iron is? Iron is Fe. It's right there. It's Fe. And he was not a guy who always made the same charge. So if he doesn't always make the same charge, that's when you're going to get a Roman numeral. I see that 3 right there. That's telling me the charge. Fe with the 3 charge. All right, second step, write the symbol and the charge of the anion. The anion is the negative thing. It's the second thing you see, chloride in this case. So what's the symbol for chloride? Right here, chloride. And do you remember the charge on chloride? Oh, just like everybody in that column, he's -1. All right, he was -1. So now what we're going to do is we're going to put the two pieces together. So what do we need more of to balance out the charges? Do we need more irons or do we need more chlorides? And how many of each? How many of each? How many would we use? Okay, I think you need more negative charges, so that means you need more chlorides. One more would help. That still ain't going to get it done though, right? If I need 3 negatives to balance out the 3 positives from the iron, if you need 3 negatives, you're going to need yet another chloride. So it should look like that. All right, so that means the formula. When Mother Nature puts this thing together, she's going to use an iron and 3 chlorides. It should look like that. All right, before we move on, let me remind you of all these charges. Oh gosh, what were they again? The next column over, -2. Nitrogen column, -3. Remember, that's how that goes. If you don't know these charges, man, it's going to be tough. The positive guys, first column is 1, second column is +2, and then we got our stragglers here. Aluminum and the fellas underneath are +3. Zinc and cadmium are 2, and then silver was 1. All right. So with that, let's move on to an example that's slightly different. Now, actually, one thing that I often have to take, because I get a lot of stomach acid, I often take like antacid tablets, right? And when my stomach isn't feeling so good, and I take an antacid tablet, I'm gonna read what's in it. I want to know what the heck I'm eating, right? So if you look on the bottle of Tums or whatever, you're going to notice that it tells you the ingredient in any antacid, Tums, Rolaids, most of them at least. It's going to say you are about to eat some calcium carbonate. Calcium carbonate. Calcium carbonate. What the heck is calcium carbonate? What's the formula for it? Calcium carbonate? If you think about every example you've done so far, just like the one we reviewed like a minute ago, we've done iron. We did iron 3 chloride, right? Every example you've seen so far has ended in "ide." But all of a sudden now, I see a name, calcium carbonate, 8. What the heck is that? What is 8? I've never seen an 8 before. Oh, there's something I haven't told you yet. Ide. If you see an ide, if like the examples we've done so far, you have only been referring to the periodic table. Use the periodic table only if it ends in ide. But if you see a name that ends in ATE, or perhaps you'll see this in a minute, ITE, there's something different. You're going to probably still use the periodic table, definitely actually, but you're going to need to look somewhere else for some help, for some information. If you have a name that ends in ATE or ITE, eights and ites, ATE or ITE, you're going to have to use the polyatomic list, So what do I mean by the polyatomic list, and where would I find it? Okay, so if you haven't already, there's a handout that you should download. It's called the polyatomic ions. We're going to be using that for this lecture, okay? So let me flip over and I'll show it to you and tell you a little bit about it, and then we'll talk about how to use it, all right? So let's get to what the heck is the polyatomic list. Oh, let's go. Come on. There we go. All right, so the polyatomic list, it's this chart, okay? And what's a polyatomic? Let's start with that. So let me write it down here. A polyatomic ion is just, we'll say, a group of atoms commonly found together with one overall charge. All right. They are on this handout. There's a bunch of them, okay, with one overall charge. So let's just start off with an example. Like a minute ago, there was a name that said calcium carbonate, right? That was in Tums. So carbonate is right here. It's right here. Let me write it down here too. Carbonate is a group of atoms. It's got a carbon, it's got 3 oxygens, and all put together, the charge on all those atoms together is -2. -2, all right? So the charge in the top corner is -2. So the only way you would know the charge on these guys, you have to look on this handout, or maybe you have them memorized at some point in your life. But for right now, we're just going to look at this handout, okay? So a carbon and 3 oxygens together, that's called carbonate, and the overall charge on that is -2. All right, now as far as this goes, these polyatomics, you're going to notice that most of them end in ATE or ITE. ATE or ITE. So if you see a name that ends in ATE or ITE, let me check a cable real quick right here. I think it fell out. We'll get to it in a minute. If you see a name that ends in ATE or ITE, that's a polyatomic. So the way I know to look at this handout, if there's a word that ends in ATE or ITE, it's a polyatomic. Now the other thing I want to point out to you, in life, there's always a few weird ones. I put all the weird ones down here in the corner. There are a couple that end in IUM. They are actually ones with positive charges. So almost all of the polyatomics, if you look all around this handout, they all are negative. -1, -2, -3, negative something. But there are a few that are positive. A few that are positive. They end in Now, there's always something a little weird. And the 2 right underneath those, ammonium and hydronium, they are really weird. They end in "ide." There's a couple of exceptions to what I'm telling you. So polyatomics, 99% of them end in ATE or ITE. There's a couple that end in IUM. Those are the positive ones. And there's a couple that end in IDE, which is a little weird. Usually if it's an IDE, that's going to be something on the periodic table like you've been seeing. All right, so with that little introduction, let's do some examples of writing formulas with polyatomic ions. All right, just another handout to use. Okay, our first 2 examples here. So you're going to need 2 handouts to do this. If you have a way of printing them and having them in front of you, that'll make life a lot easier. I'm going to try to show you on the screen, but it might be a little tricky. So still need to be using our friend, the periodic table. And we're now also going to need to start using this polyatomic list. So between both of them, we should be able to write the formula for pretty much any ionic compound. All right, so let's go ahead and get started. So the first one is actually the thing that was in Rolaids, or Tums, I guess it was, that I showed you a minute ago, calcium carbonate. So we use the same method we've been using all of this lecture, right? You write down the cation, you write down its symbol and charge on the cation. So the cation is the first thing, that's carbonate. Carbonate, it's right here, it's in the +2 column. So we have calcium with a +2 charge. And then we get to this second part of this name, and I noticed that it ends in 8, carbon 8, 8, 8. If it ends in ATE, that tells me it's a polyatomic. I'm not going to find it on the periodic table. I'm going to find it on the polyatomic list. And again, this is one of the ones I talked about earlier. It's right there. It says CO3 2-. Now, we need to put these two together to get the answer. So if I want to put them together, we have calcium with a +2 charge, carbonate with a -2 charge. So actually, right now, the charges already balance out. I have a +2 and a -2. We're set. We don't need any more subscripts or anything. It's just going to be CaCO3. All right, should look like that. All right, let's do another one. Lithium phosphate. All right. So for lithium again, that's an element. It's on the periodic table. It's right here, and it's in that +1 column. So one thing, the cation is lithium. Now I get to the second word, phosphite, lithium phosphite. Phosphite, if it ends in ITE, that is a polyatomic. 8s and 8s are polyatomic. So it's right here, actually. Phosphite. The periodic table tells, or the polyatomic list, I should say, tells me that it's PO3 3-. Now, if I want to balance out those charges, this time I have to do a little work, don't I? Because they don't balance already. So what do you need more of this time? Do you need more lithiums or more phosphites? I think you're going to need more lithiums, aren't you? Because you need more positives. Another one? Shoot, that still isn't going to do it, right? Because I only have 2 positives and I still got 3 negatives. So I need yet even one more. Should be this. All right. So now we're in business. I got 3 positives. Each lithium gives me a +1 and 3 of them. That's my +3. The phosphite all by itself, phosphite by itself, is -3. So the formula just tells me who you put together. Mother Nature is going to need to use 3 lithiums and a phosphite. Should look like that. All right, with that, that's a couple. Let's do a couple more. Let's move on to the next page and we'll do a couple more. All right. All right, our last 2 examples on this, All right, so I see manganese 1 sulfite and then beryllium nitrate. What are they going to be the formulas for those? So let's start off with manganese 1 sulfite. So manganese, oh, what's the symbol for manganese? Do you remember? Oh, it's Mn. It's Mn. And if I find it on the periodic table, it's right here. Now remember, that middle area is where we find ones that don't have a constant charge. So that's why they're giving me a Roman numeral. If you see a Roman numeral, that's the charge. All right, now let's move on and write the formula for the second part. Sulfite. All right, symbol and charge for sulfite. So sulfite, I-T-E. It's got to be a polyatomic. Oh, where are you? Oh, you're right here. There you are. All right, if I look on that handout, it tells me it's SO3 2-. All right, so we got to balance out those charges. More manganeses and more sulfites. What do you need more of? Manganeses, don't you? Because you only have 1 positive right now, and there's 2 negatives. So I need more positives. I think 1 more should do it. It should look like that. All right, put it all together. Give me my final answer, my formula. Mn2SO3. Should look like that. All right. Our final example. Let's do our last one here. Beryllium nitrate. Beryllium nitrate. All right. Right, I find the symbol and charge of beryllium. Beryllium, hey, that's an element. It's right here. What's the charge on beryllium? Okay, hopefully you know it's +2. Look at where it is on the periodic table. And then we get to nitrate. So nitrate is right here. This is nitrate. It's a polyatomic. Oh yeah, it's got to be a polyatomic. It ends in 8. If you end in 8 or 8, you're a polyatomic. So nitrate would be NO3 -1. All right. So let's think about it for a second. What do you need more of? Positives or negatives? You need more negatives, don't you? So how are you going to get another negative? You're going to have another nitrate. All right, now this is actually going to bring up something that you haven't seen before. I need 2 nitrates for this to work out, to get my 2 negatives, to balance out the 2 positives. So the way that I would get that to happen, the way I would show you that there are two nitrates is I would write BeNO3, and then I needed two of them. So you put the whole thing in parentheses, and you put a 2 on the outside. There's a 2 on the outside of the parentheses there. So we only use parentheses around polyatomics, and we only use them when we need more than one of them. If you're doing 2 of the same polyatomic, you'll use parentheses, or 3 of them, or whatever. So parentheses would only go around a polyatomic when you need a couple of them, or 3 of them, whatever it might be. All right, so that's it for writing formulas. Now, we got to be able to go the other way too. So let's do just a few here towards the end of our lecture where we're doing the other thing. What if I give you the formula? Can you tell me the name of stuff? How do you do that? All right, well, let's go try it out. All right, so if I give you the formula of something and I want you to tell me the name, this is how you do it. So here's some formulas. So K2O or FeCl3, or this one Ni2SO4 right there. All right, and if I want to write the names of those things, you know, the words, whatever it is, sodium something or whatever it is, how do you do that? Well, the first thing you do is you write the name of the cation. Oops, messed up there. There we go. You write the name of the cation. That's going to be the first thing you see, right? Now, that's typically the metal. The metal will be the first thing in the formula, so you just write the name of that thing. Now, where it gets a little tricky is once in a while you need a Roman numeral, so we might see a Roman numeral, all right? We'll talk about when you use a Roman numeral in just a minute. And then after you write the name of the cation, you write the name of the anion, all right? So the name, it goes just like the same order as the formula. You write the name of the first thing, and then write the name of the second thing. Sometimes you need a Roman numeral. All right, so let's do our examples. K. What does K stand for? What does K stand for? K stands for potassium. You write the name of the first thing, potassium. All right. Now you write the name of the anion. That's the second thing. Now, don't write oxygen, okay? I know it says O, but when oxygen's part of an ionic compound, oxygen, when it's got a negative charge, and I know that because if part of an ionic compound is going to be negative, don't say oxygen anymore. What should you be saying? Oxide. This would be potassium oxide. All right. Now, I've talked about everything except this part in parentheses. This is the part you got to be careful of. In some names, you see a Roman numeral, and in some names you don't. So the last thing I want you to think about is, do I need a Roman numeral? Should there be a Roman numeral right here, like a 1 or a 2 or a 3, right? Sometimes you'll see Roman numerals right there in the middle. Is this one of those times? Well, how do we know? Look at where potassium is. Potassium is always +1. You do not use Roman numerals with your always and forevers. So these guys will not need a Roman numeral. It's just potassium. Don't need a Roman numeral. These guys will not need a Roman numeral because they're always 2. Don't need a Roman numeral to tell me that. I know that. And then these guys over here that we've been talking about, these little straggler guys, they won't need Roman numerals either. Every other element, every other metal, all the ones down here and over here, you need a Roman numeral with. But not the guys who always make the same charge. All right? So, in this case, potassium always has a charge of 1. It's right here. It's always 1. You do not need to write the charge. You don't need to tell me the charge. I know it's 1. So it's just going to be potassium oxide. That's it. Potassium does not get a Roman numeral. All right, it's done. Okay. All right, let's do another one. FeCl3. Write the name of the metal. The first thing you see. What's Fe stand for? Fe is iron. Then you write the name of Cl. What's Cl stand for? All right, it's chlorine, but when it's part of a compound, we don't call it chlorine anymore. It's got a negative charge. Chloride. And then we have to do the tricky part. So we wrote the name of the metal, we wrote the cation, wrote the name of the anion. That's what we've done. Now, what about this middle part? What about this Roman numeral thing here? Do we need a Roman numeral right here? Sometimes there's going to be one and sometimes there won't be. Well, let's look at where iron is on the periodic table. You have a guess, Roman numeral or not? Well, this is one where we need it, all right? Iron does not always do the same thing, so we need a Roman numeral with iron, okay? So iron needs a Roman numeral. So now we're going to have to figure out what it is. So the way I'm going to figure it out, let me go up to the top here. We'll do a little scratch work. Iron, not and always and forever, needs a Roman numeral. So I know this compound. If you look at the formula, what's in it? There's one iron slapped together with 3 chlorides. Now, I really want to know the charge on the iron, right? That's what the Roman numeral is. It's the charge on the metal. Now, how am I going to know that? Well, really what you want to start off doing, look at the other thing, the chloride. Now, chloride is -1, right? Anything in that halogen column is -1. So if chloride is -1 and there's 3 of them, now how did I know there was 3 of them? Why did I say there's 3 of them? That's what the subscript means. There's 3 of them. Well, thinking about how compounds work, if you have 3 negatives, you have to have 3 positives. So the charge on the iron is going to be whatever it takes to balance out the chloride's charge. Altogether, those chlorides make -3, so the iron has to be +3. So the Roman numeral right here is a 3. It should be a 3. All right. One more example. All right. It takes a little, this can be a little tricky, can it? Often this is the trickiest thing. All right. So let's see if we can do one more maybe to make sure we're okay on this. All right, so we're going to write the name of the first thing. The first thing is Ni in our next example. Ni stands for nickel. All right, that's what Ni is. And then you get to SO4. What the heck is SO4? Well, SO4 is actually a polyatomic. It's actually a polyatomic. Kind of hard for me to show you that polyatomic list right now, but it's on there. So you're not going to call it like sulfur oxide or something. If you look on the polyatomic list, they tell you SO4 is called, it's right towards the top in the middle. It's called sulfate. You'll see it on the polyatomic list, all right? So this thing is going to be nickel sulfate. Now, there's only one last thing I got to do, and it's the trickiest thing of all. Figure out if there's a Roman numeral, and if there is, what it is. So first off, with nickel, do we use a Roman numeral? Yeah, we will. We're going to use a Roman numeral. All right. So we will be using a Roman numeral. Now, the next thing you have to do is you have to figure out what it's going to be. So let's figure that part out. I'm going to think about who's in this compound. So I'm going to think about how many are in this compound. There's actually nickel. Now, actually, if you look at the formula, there's actually 2 nickels. Ni2. And that SO4 is a polyatomic. It's on your handout. It's SO4. And the polyatomic tells me, the list tells me it's 2-. So that's on your polyatomic list right there. It says SO4 2-. Now, what am I looking for? What is the Roman numeral? What does the Roman numeral tell me? It tells me the charge on the metal. Now, I know there's 2 nickels. How? Because of the subscript after the nickel, Ni2. That's how I know there's 2. I want to know the charge on each nickel. So what does each one have to be? Because that's what the Roman numeral is. What's the charge on each nickel? Now, if you work it out, if you think about it, if it's got a balance, if I've got 2 negatives from the sulfate, it'll work. I'll be balanced if each nickel is +1. Does that work? Yeah, because I get +2 total from the 2 nickels together, and that balances out my -2 on the sulfate. So the Roman numeral is the charge, not the total. It's the charge on each nickel, which is a 1. All right, this can be pretty confusing, and this is another one of these ones you might want to rewind and watch part of this again if it didn't make sense. So this Roman numeral part, that's the part that always messes you up. All right, so that's all I'm going to do on naming ionic compounds. So we'll get some practice in class and in sapling to get a little more familiar with this. But hopefully it makes sense. If not, you can contact me and I'll try to help you out the best I can. All right, so that's the end of lecture 9, and I will see you next time.